Hello, this is a brief presentation regarding the article published in the Journal of Sport and Health Science entitled Residual Force Enhancement in Human Skeletal Muscles, a Systematic Review and Meta-Analysis. In black, we see the force capacity of a muscle during an isometric contraction at a given length. In blue, the force capacity of a muscle that is activated in a shortened length and then is stretched to the same length as the purely isometric contraction shown in black. As we can see, muscle's force capacity during an eccentric contraction is greater than in an isometric. This results from the muscle's force-velocity relationship and can be explained by the way crossbreeds are thought to interact and produce force. Less understood, however, is the enhancement in force capacity that persists after the stretch. This muscle property is called residual force enhancement and is typically measured as the increase in isometric force capacity that occurs after an active stretch compared to a purely isometric contraction at the same activation level and muscle fiber length. Residual force enhancement has been observed across muscle structural levels, from isolated sarcomere to muscles. Except for the isolated sarcomere preparation, for which only one stretch amplitude has been tested, a dependence of residual force enhancement on stretch amplitude has been observed in isolated muscle preparations. There has been a great interest in investigating possible roles for residual force enhancement in the performance of in vivo contractions. The most common approach used is testing whether an isometric torque capacity of a muscle group at a given joint and activation level is greater when the contraction is preceded by an eccentric contraction. This has been called residual torque enhancement. However, the presence and magnitude of residual torque enhancement seem to vary considerably across studies in humans. Additionally, the dependence of residual torque enhancement on the amplitude of the eccentric contraction and on the contraction type is not clear in human studies. Given the increasing number of studies in humans, we performed a systematic review and meta-analysis to identify and appraise the existing evidence towards the presence of residual torque enhancement in humans. Specifically, we aim to describe the main outcomes and procedures used to investigate residual force enhancement in human voluntary and electrically evoked contractions. Also to appraise the existing evidence with regards to potential risk of bias and to assess the effect of an immediate history of contraction, of eccentric contraction, on the subsequent torque capacity of voluntary and electrically evoked contractions. We follow the recommendations from PRISMA for this systematic review, and we searched in predefined electronic database for the following keywords: residual force enhancement or force enhancement. Additionally, reference lists of selected papers were screened for studies of potential relevance to this systematic review. For the review, we included studies that were complete, original, focused on skeletal muscle, and that compare purely isometric contractions versus isometric contractions preceded by an active stretch. For the meta-analysis, further inclusion criteria were included. Experiments were not torque clamped, and also studies had to show mean and standard error or standard deviation of torque in Newton meters. Study quality was assessed independently by two authors. From 1,341 potentially relevant studies retrieved from electronic databases, 45 original studies met the inclusion criteria and were reviewed. 38 of the 45 studies were included in the meta-analysis. The quality assessment showed that procedures varied across studies. Total study scoring varied from 3 to 11 out of 16 items that were evaluated. Study blindness and control of fascicle length and the region of the force length relationship were the items that most often were not accounted in the literature. Most common outcomes were torque and EMG, and some studies also looked into neuromuscular economy. The majority of studies, 33 out of 45, reported residual torque enhancement in voluntary contractions. Elected characteristics of the included studies and the observed percentage change in torque and EMG are described in Table 2, supplementary material to this manuscript. Torque enhancement was observed for voluntary contractions, but this effect was found to differ across muscles. A significant residual torque enhancement was observed for knee extensors, adductor pollices, ankle dorsiflexors, ankle plantar flexors. No significant overall effect was observed for elbow flexors and knee flexors. Additionally, no studies were found on the proximal muscles around the shoulder and the hip. The funnel plot indicates that negative effect size in experiments involving voluntary contractions might have been suppressed due to publication bias. Trim and fill method was used to correct the random effect model outcome by adding 10 effect sizes. The overall effect of residual torque enhancement in voluntary contractions, corrected for publication bias, resulted in a significant standardized mean difference of 0.21. Significant residual torque enhancement were also observed for electrically evoked contractions with a standardized mean difference of 0.84. Comparisons across muscles were not possible due to the limited number of studies involving electrically stimulated muscles. The difference in residual torque enhancement between voluntary and electrically evoked contractions highlights the potential role of the nervous system in modulating residual torque enhancement in humans. In this graph, we see on the y-axis the residual torque enhancement effect, and in the x-axis, the angular amplitude of the eccentric contraction expressed as a percentage of the full range of motion available for that joint of interest. Meta-regressions revealed that the relative angular amplitude of the eccentric contraction was not associated with the magnitude of the effect size for both voluntary and electrically evoked contractions. In summary, for this review and meta-analysis, we can conclude that procedures used to investigate residual force enhancement in vivo vary considerably in the literature, and the main outcome used to assess residual force enhancement is the increase in torque. Residual torque enhancement seems to be present in some muscle groups during voluntary and electrically evoked contractions. A greater effect is observed for electrically evoked contractions compared to voluntary contractions. When studies are pooled, including different muscle groups, activation levels, and phenotypes, no effect of angular stretch amplitude on the magnitude of residual torque enhancement was observed. Future studies should focus on different ways to capture the significance of residual force enhancement and should avoid the source of bias identified in these studies. Additionally, muscles at proximal joints, such as the ones around the shoulder and the hip, should be evaluated in future studies. I would like to thank you for your attention, and please refer to the manuscript for more information. Thank you.